ISO 18562 testing is an international biocompatibility standard that is a complement to ISO 10993 testing, but is more specific for respiratory devices. It is a standard that is to be used in conjunction with and not in place of ISO 10993, but is able to more adequately capture the potential unique risks that respiratory devices may pose to patients. PSN Labs offers all three parts of the ISO 18562 standard testing. So the first part, ISO 18562-2, is the particulate standard. Particulate emissions in respiratory devices are an extremely important consideration when you're looking at potential patient risks. So respiratory devices are typically moving large volumes of air to the patient in a positive pressure situation. So of course, this is something that's not passive. You're not passively inhaling the therapy. You're getting it delivered more forcefully in a positive pressure situation. Medical devices, especially respiratory medical devices, have moving parts, have materials, grease, lubricants, mechanical portions that move. All of these things can contribute to a particulate risk. And so part of the -2 standard, the particulate standard, is measuring the emissions of those particulates, quantifying the concentration of those particulates over time, and then comparing them to established health-based thresholds to ensure that that respiratory device isn't outputting anything that could be considered hazardous for the patient. PSN also offers ISO 18562-3 testing, which is the volatile organic compound emissions portion of the standard. This part of the standard measures the actual volatile emissions that the respiratory device may give out as it's functioning and what is being delivered to the patient in a volatile sense. So what we have is a unique setup where we've isolated the medical device in a system that has what we call a zero air generator. So volatile-free emissions are going through the device at this prescribed flow rate. And we have unique hookups that allow us to sample directly from the gas pathway of the device while isolating all of the ambient or environmental conditions so that we are really quantitatively identifying the volatile emissions that come off the respiratory device and then being able to determine their concentrations so that we can effectively assess toxicological risks to the patient. The ISO 18562-4 portion of the standard specifically addresses the risk of condensate getting to the patient. And this is very related to the ISO 10993-18 standard about extractables and leachables. So essentially what we're looking at is the same thing. What is potentially leached out from the respiratory device? Now the -4 standard covers what we call the humidified gas pathway. So these are the portions of a respiratory device that interface with the exhaled patient breath and are potentially being purposely humidified downstream in a patient circuit setup. So -4 testing, what we offer is the ability to create a clinically relevant setup where we can create a closed loop system and produce condensate in your device and then later on chemically analyze that condensate. We do often use techniques and share between the two. So ISO 10993-18 and 18562-4 are complementary to one another. -4 is a more clinically relevant setup and advises you to use only those solvents which the patient could truly be exposed to, but overall, both -4 and -18 of 10993 are addressing that risk of what is coming out of the material, what is coming out of that device, what could be leached out, and how does that relate to toxicological risk. As the principal biocompatibility scientist, what I'm able to do is utilize all of the testing that we offer here at PSN Labs, create a custom biocompatibility evaluation plan. If you're a respiratory device, we're adding 18562 into that mix as well. And using all of these endpoints to be able to then assess the clinically relevant biological risk that your device poses, run those experiments, get that data, look at the toxicological risk for those portions of the testing that need those analyses and assessments, and then wrap this all up into a biological evaluation, a biocompatibility evaluation that then says whether your device is safe from a biological and toxicological risk perspective. This biocompatibility evaluation is then often used for things like 510(k) submissions, notified body submissions, product launches. We often have people changing legacy devices and needing to do a letter to file. All of those processes in the regulatory space for a medical device can be addressed with the biocompatibility evaluations. PSN Labs has a number of different business units that help us with this clinically relevant setup. So we actually have a machining shop in-house. We have the capability of making any kind of part to interface with the medical device so that we get something that's really clinically relevant. So for example, you have a patient circuit and a mask, and there's only certain parts of that device that actually interface with the respiratory system of the patient. And we don't want to test everything in that circuit. We don't want to test the outside of that circuit because that's not actually interfacing with the respiratory tissue. So what we have the ability to do is create custom setups so that we don't have to cut the medical device when it's not necessary, that we don't have to introduce or potentially have background contamination. And we're really just looking at, in the case of ISO 10993-18, we're really just looking at the materials, the surface areas that make contact with the patient. We don't want to cut up a respiratory device and expose surface areas that never get exposed to the patient. We sometimes do custom fills for things like patient circuits, where we really truly then can get the extractable, leachable profile from the materials that are interfacing with the patient gas pathway. And PSN's other business units that have the ability to custom mold adapters and to custom mold fixtures allow for these clinically relevant setups so that downstream, when we do the toxicological risk analysis, we're truly getting potential risk to the patient and are able to effectively mitigate hazards because we are looking at what the patient could get each day. And that is something that is so important when you're looking at the realm of medical device safety and efficacy. We don't want to introduce artifacts or materials that don't actually make contact with the patient and are not clinically relevant. So the philosophy at our laboratory with the biocompatibility and toxicology testing is we're not trying to make your device work. We are actually looking at the clinically relevant risk, and we are reporting on what that biocompatibility or toxicological risk is. Other CROs, they can take the device in, test the device, output something. We're there to look at your materials of construction, look at the patient risk, look at the clinical duration, the clinical contact, and then report on what your toxicology risk is.